Hello everyone, I Sindhushri MV, Assistant Professor, Department of Mathematics, Maharaja Institute of Technology, Mysore. In the last class, I explained the composite function of the single variable and the two variables. Today, I am going to discuss the maxima and minima for a function of two variables. First, I explain what is the maxima and minima. The function f of x is said to be a maximum at x equal to a. There exists a neighborhood at a point, say a plus h, then f of a is greater than f of a plus h, where h is very small. Then the function is said to be a maximum at x equal to a. Similarly, the function f of x is said to be a minimum if f of a is less than f of a plus h. This is with respect to a single variable. So my topic is the maxima and minima for a function of two variables. Suppose I consider the two variables x and y, that is f of x comma y. Then the function f of x comma y is said to be a maximum at a point a comma b. Then there exists a neighborhood, say a plus h and b plus k, where h and k are very small. Then f of a comma b is greater than f of a plus h comma b plus k. Then the function is said to be a maximum. Similarly, the f of a comma b is less than f of a plus h comma b plus k. Then the given function is said to be minimum at the point a comma b. And also the function is said to be an extreme value either it is a maximum or the minimum at the point a comma b. Then how to find the maxima and minima for the function of two variables? You have the procedure. First, we have to find the stationary points x comma y such that fx equals 0 and fy equals 0. That is, you have to find the fx. Fx means the given function you have to differentiate with respect to x, then equal to 0. Then differentiate the given function with respect to y, then equal to 0. You will get the stationary points. Then the second procedure, you have to find the second derivatives for the given function. That is, first one, fxx, this is with respect to x, differentiate the given function with respect to x twice. Then fx you differentiate with respect to y, or fy you differentiate with respect to x, both are same. Next, differentiate the given function f with respect to y two times. Then take the first one as a, the second one b, the third one as c. Then we have to evaluate these at all the stationary points and compute ac minus b square. Then the first condition, in that you have the first condition, if ac minus b square is greater than 0 and a is less than 0, then the given function is said to be maximum at x0 comma y0. x0 comma y0 is the stationary point. Then the second condition, if ac minus b square is greater than 0 and a is greater than 0, then the given function is said to be minimum at x0 comma y0. Then the third possibility, suppose the ac minus b square is less than 0 at x0 comma y0, then f is not an extreme value. Then the fourth possibility, if ac minus b square is equal to 0 at x0 comma y0, then the case is doubtful, we need the further investigation. So these are the procedure to find the given function is the maxima and minima at x0 comma y0. Next, the problems. So they will ask to find the extreme values for the given function f of x comma y, x cube plus y cube minus 3x minus 12y plus 20. You have to find the stationary points, that is consider the first order differentiation fx and fy then equal to 0. Solution. Differentiate the given function with respect to x first. So the first one, so x cube differentiation 3x square, the y cube differentiation 0 minus 3x differentiation is 3, the 12y differentiation 0 and the 20 is also constant, the differentiation is 0. Next, differentiate with respect to y. So the x cube differentiation 0, y cube differentiation 3y square minus 3x differentiation is 0 minus 12, the differentiation of y is 1 and the 20, the differentiation is constant. Then equate this fx and fy to 0. So fx equal to 0 and fy equal to 0. So the first term, it is 3x square minus 3 equals 0. The second part, 3y square minus 12 equals 0. So from the first one, you will get x square equals 3x square equals 3 and the x square equals 1, x equals plus or minus 1. So in the second part, it is 3y square equals 12. So y square equals 12 divided by 3, you will get 4 and y equals plus or minus 2. Next, write the stationary points. Therefore, the stationary points are so you have to write the stationary points in the order. So the stationary points are, so write the ordered pair x comma y. So the first possibility here, you have the plus 1. So here the plus 2. Next 1 and minus 2. Next minus 1 and plus 2. Last one minus 1 and minus 2. These are the 4 possibilities of the stationary points. Next, find the second order derivative for the given function f of x comma y. So the second order derivatives, fxx, you have to differentiate the fx with respect to x again. Fyy, you have to differentiate fy with respect to y again. Fxy, so the first differentiation fxx, so x square differentiation is 2x, multiplication of 3, you will get the 6x and minus 3 differentiation, the constant differentiation is 0. Similarly, you differentiate this one, second part, fy with respect to x, differentiate this fy with respect to x, you will get the term 0. Since you have the 3y square, the differentiation is 0, 12, the constant term, the differentiation is 0. Next, differentiate fy again with respect to y. So here you have the 3y square, differentiate that, you will get the 6y minus 12, the differentiation is 0. So mark this point, the first one is A, second one B, third one C. Next, we have to evaluate this at all the stationary points, then compute AC minus B square. For that, I considered this table. So first I mentioned the stationary points. These are the stationary points. Then A is 6x, B is 0, C is 6y. Then AC minus B square you have to compute. Then you have to write the conclusion. So the first one, put x equals 1 and the y equals 2. There is the xy and last one x and y terms. So the first one, put x equal to 1, you will get 6. Second one, again x equal to 1. The third one, x equal to minus 1. Fourth one, x equal to minus 1. So the next b term is 0 for all the cases. Next 6y. So the first 6 into 2 will get the 12. Second term is minus 2. Third one is plus 2. So the fourth one is also minus 2. Then you have to compute AC minus B square. So these two are the AC. The first one is 72, second one minus 72, this is also minus 72 and the plus 72. So you know the condition to find the maxima and minima for the given function. So AC minus B square, here the AC minus B square is greater than 0 and A is also greater than 0, then the function is said to be minimum point. This is the minimum. If AC minus B square is less than 0, then AC minus B square is less than 0, then the given function is not an extreme value at this stationary point. The third one, then that point is also called the saddle point. Similarly, the third one, it is less than 0, again it is the saddle point. The fourth one, it is greater than 0 and A is less than 0, then it is the maximum point. So the first stationary point, you got the minimum point. Second one, you got the saddle point. The third one is the saddle point. The fourth one is the maximum point. So the given function is the maximum at, that is f is maximum at the point minus 1 comma minus 2. So if you substitute the minus 1 and minus 2 for the given function f of x comma y, you will get the maximum point, that is f of minus 1 comma minus 2, you will get the maximum point 38. Next, similarly, the given function is minimum at the stationary point 1 comma 2. So if you substitute these points for the given function f of x comma y, you will get the minimum point 2. So this is the procedure to find the maxima and minima for the function with respect to the two variables. The next problem, the given the function f of x comma y is x cube plus 3x square, 3xy square minus 3x square minus 3y square plus 4. So this is same as the previous problem. First you have to find the stationary points by considering the fx and fy equal to 0. So first I take the first differentiation for the given function with respect to x. So the x cube differentiation is 3x square. Here the x differentiation 1, you will get the 3y square. Next x square differentiation is 2x. Multiplication of 3 will get the 6x. Then 3y square, the differentiation 0 and the constant term differentiation is 0. Similarly, with respect to y, fy, the first differentiation is 0. Next, y square differentiation is 2y. Multiplication of this, you will get the 6xy. X square differentiation 0 and the y square differentiation is 2y. Multiplication of 3, you will get the 6y. And the fourth, the constant term differentiation 0. Next, equate this fx and fy to 0. You will get the stationary points. So fx equals 0 and fy equals 0. So the first term, it is 3x square plus 3y square minus 6x equals 0. The second part, it is 6xy minus 6y equals 0. In the second term, you take the y outside since you have the common. 6x minus 6 equals 0. So equate the y term, since you have the product, equate two terms to 0. So 6x minus 6 equals 0. So here 6x equals 6, you will get the x equals 1. Then substitute x equal to 1 and y equal to 0 in the first expression. So we will get the another points. So the first one, put x equals 1. So we will get the first one, 3 plus 3y square minus 6 equals 0. So 3 equals minus 3 equals 0. So we will get the y square equals 1 or y equals plus or minus 1. So for the first one at x equals 0, you got the y is plus or minus 1. The same case, you take the second term, put y equals 0. For this expression, you will get the 3x square minus 6x equals 0. Or you take the 3x outside, you will get the x minus 2 equals 0. So you got the x equals 0 and x equals 2. Then you have to consider the stationary points. So the stationary points are the first possibility at x equals 1, the y you got the plus 1 and the minus 1, and the y equal to 0 you got the x equal to 0, and the y equal to 0 you got the x equals 2. These are the stationary points. In the next procedure, you have to find the second order derivatives. So the first one, fxx. So we will get the first one 6x, second term 0, third term is 6. Next, fxy, differentiate fy with respect to x, you will get the fxy. So the first term is 6y, the second term 0. Then the third one, differentiate fy with respect to y again, you will get the third one. So with respect to y, you will get the 6x minus 6. Then mark this, the first one as A, second one B, third one C. Then evaluate this at all the stationary points, then compute the AC minus B square. For that I consider the table. So the first one, first I consider the stationary points. So 1 and 1, 1 minus 1. So for that I construct the table. So these are the stationary points, then A, B, C, and you have to compute the AC minus B square, then you have to write the conclusion. So the first part, put x equal to 1 and y equal to 1, you will get the first term is 6 minus 6, you will get the 0. Similarly, the second part is 0, the third one 0 minus 6, the fourth one 12 minus 6. Similarly, this one 6, the second one minus 6, third one 0, and the fourth one is also 0. Then the last one, put x equal to 1, you will get the 0. Next, the second part is also 0. Third one, you will get the minus 6. Fourth one, 12 minus 6, you will get the 6. Then compute AC minus B square. So A into C minus B square. So minus 6 square, you will get the minus 36. Similarly, the second part, minus of minus 6 whole square, again you will get the minus 36. Third one, AC minus B square. So A into C, you will get the plus 36. Again, the last one, you will get the plus 36. So you know the procedure, if the AC minus B square is less than 0, then you have to write the saddle point. Then you have to write this is the saddle point. Again here it is less than 0, then write the saddle point. Then AC minus B square is greater than 0 and A is less than 0, then the given function is the maximum at this point. If AC minus B square is greater than 0 and A is greater than 0, then the given function is the minimum at this point. You have to write. Next, you have to find what is that maximum and minimum point. So here the function is maximum at the stationary point 0, 0, minimum at the 2, 0. If you substitute these points to the given function, So x cube plus 3xy square minus 3x square minus 3y square plus 4, you will get the maximum and minimum point. So I will write it here. The given function f is maximum at the point 0, 0, you will get the 4. So the maximum point is 4. Similarly, if you substitute the minimum point, that is 2, 0, you will get the minimum value, which is 0. You will get the minimum value 0. So the maximum is 4, the minimum value is 0. So next problem, they asked to examine the given function f of x comma y, 1 plus sine x square plus y square is an extremum. Extremum means you have to find the maximum or minimum value for the given function. So the first, as usual, you have to consider the given function, differentiate with respect to xy, then equal to 0. So the first case, first I consider the given function. Next, find the first derivative with respect to x. So the one differentiation 0, the sign differentiation is the cos x square plus y square. Differentiate x square plus y square with respect to x, so 2x plus 0. Similarly, you take the next differentiation fy, the one differentiation 0, differentiate the sign again, you will get the cos x square plus y square, then x square differentiation 0, y square differentiation 2y. Then equate this to 0. So the first term fx equals 0 and the fy term equals 0. So the first part, it is 2x cos x square plus y square equals 0. Similarly, 2y cos x square plus y square equals 0. Here equate both the terms to 0. Here the first one, the variable x equal to 0. The second part, if you solve this second part, again you will get the x equal to 0. For the y equal to, again you will get the x equal to 0. So similarly for the second term, 2 is not equal to 0. So the y is equal to 0. Similarly, you can solve this, again you will get the y equal to 0. So you will get only one stationary points in this case. So the stationary point is x comma y is 0, 0. So there is only one stationary point in this case. So the next you have to find the second order derivative by considering, that is fxx, differentiate fx with respect to x again. So keep the 2 outside, the first term, so write the first term as it is, differentiate the cos, you will get the minus sine x square plus y square. Differentiate x square plus y square, you will get the 2x and the y square differentiation 0. So next, plus x differentiation is 1, write the second term as it is. Next, fxy, differentiate y with respect to x. So with respect to x means you have to keep this 2y as a constant since you have the product. This cos differentiation minus sine x square plus y square. Differentiation of x square is 2x. The y square term is 0. Next, fyy, differentiate fy with respect to y. So keep the 2 outside. Since you have the y and the cos trigonometric term, you have to apply the product rule. So the first term, differentiation of sine, differentiation of cos, minus sine x square plus y square. With respect to y, the x square differentiation 0, the y square differentiation 2y, plus the y differentiation is 1, keep the second term as it is, x square plus y square. Then you have to evaluate at the stationary point 0, 0, then compute AC minus B square. So for that, at 0, 0, first to see the A point. So I consider this as A, this is B, and this term is C. This multiplication, the first term is multiplication of x, you will get the 0. The second term cos 0 you have, the cos 0 is 1, so we will get the 2 is the answer. Similarly, B term, so the B term is the multiplication of x and y, both the terms are 0, you will get the 0. The third part, C equals, it is 2 times of, the first term is multiplication of y, again you will get the 0. The second term is cos 0, you will get the 1. So AC minus B square equals 4 minus 0, you will get the 4. Since the AC minus B square is greater than 0 and A equals 2, which is also greater than 0, the given function is the minimum at the point 0, 0. Therefore, f is minimum at 0, 0. So the point is f of x comma y, you substitute to the given function, you will get the 1 plus, or f of 0, 0, you will get the 1 plus sine 0, the sine 0 is 0. So you will get the minimum point of the function is 1. So next problem, you have to examine the given function f of x comma y, the sin x plus sin y plus sin x plus y for extreme values. So as usual, for the extreme values, you have to find the maximum or the minimum point for the given function. First, you have to consider the first derivative of the given function, then equal to 0. You will get the stationary points. So the first one, write the solution. So differentiate the given function with respect to x. So sin x differentiation cos x, cos y differentiation is 0, sin x plus y differentiation cos x plus y, differentiation of x is 1 and the y differentiation 0. Similarly, the second one, differentiate with respect to y. So it is 0, sin y differentiation cos y, then cos sin x plus y differentiation cos x plus y, differentiation of x is 0, the y differentiation is 1. Then equate this first order derivative to 0. So the first one, fx equals 0 and fy equals 0. So in the first term, the cos x plus y plus cos x equals 0. In the second term, cos y plus the cos x plus y equals 0. So using the first term, you can rewrite this, the cos x plus y equals minus cos x. Similarly, cos x plus y equals minus cos y. Since the LHS part is same, you can equate these two terms. So write the minus cos x equals minus cos y. By equating these two, you can write x equals y or y equals x. Then to get the stationary points, substitute x equal to y or y equal to x to any one of these expressions. So I substitute y equal to x in the first expression. So for this expression, the first term, it is cos 2x plus cos x equals 0. You can write the cos 2x as the 2 cos square x minus 1 plus cos x equals 0. You can rewrite this equation, 2 cos square x plus cos x minus 1 equals 0. So this is the quadratic equation in terms of the cos x, or you can take the factorization, you will get the stationary points. So you can write this 2 cos square x, 2 cos x minus cos x minus 1 equals 0. So consider these 2 points, take the 2 cos x as a common term. So cos x plus 1, in the second part, take the minus 1 as outside, you will get the cos x plus 1 equals 0. So from these two terms, take the cos x plus 1 as a common term. So in the first term you have 2 cos x, second term minus 1 equals 0. Since you have the product, equate these terms to 0. So cos x plus 1 equals 0 and the 2 cos x minus 1 equals 0. So cos x equals minus 1, x equals cos inverse minus 1. You know the cos inverse minus 1 is pi minus pi. Since you have the negative sign, we will get the minus pi. Similarly, the second part, it is 2 cos x equals 1, cos x equals 1 by 2 or x equals cos inverse 1 by 2, you will get the pi by 3. Since x equal to y or y equal to x you consider, you got the x points. So now you write the stationary points. Therefore, the stationary points are so minus pi. Since x equal to y, the y point is also minus pi and minus pi, pi by 3 comma pi by 3. Next you have to find the second order derivative for the given function. Evaluate at all these stationary points. So the second derivative, you know the first differentiation. So consider the second differentiation fxn. So we will get the minus sin x. Next minus sin x plus y. So the next one, differentiate fy with respect to x. Cos y differentiation 0 and the cos x plus y, it is minus sin x plus y. Similarly, differentiate fy with respect to y again. The first term, it is minus sin y minus sin x plus y. So I consider this as A and this is B and this is C. So to evaluate, next you have to evaluate this at all the stationary points, then compute AC minus B square. For that I construct the table. So first I write the stationary points. It is minus pi and minus pi and pi by 3 and pi by 3. Next to write this is A, B, C, AC minus B square. At last you have to write the conclusion. So for the first point, minus pi and minus pi, since the sin minus pi or sin pi, you will get the 0. So this A part is 0, B term is also 0, C is also 0. So the A, B, C and all you will get 0. So the AC minus B square is also 0. If the AC minus B square equal to 0, so you have to write the case is doubtful, we need the further investigation. So this need further investigation you have to write. Second part, for the pi by 3 and pi by 3, for the first one minus sin pi by 3 you will get the minus root 3 by 2. Here sin 2 pi by 3 you will get the again root 3 by 2. Negative sign minus 2 root 3 by 2 you will get the minus root 3. Similarly, second term, minus sin 2 pi by 3, you will get the minus root 3 divided by 2. Third part, again, the same as A, you will get the minus root 3. AC minus B square. So, this 2, AC, you will get the 3 minus B square, it is 3 divided by 4. So, we will get the answer 9 by 4. Since AC minus B square is greater than 0, and A is less than 0, the given function is maximum at this point. Therefore, at last you write, therefore f is maximum at pi by 3 comma pi by 3. Substitute pi by 3 and pi by 3 to the given function. So, to the given function, sin x plus sin y plus sin x plus y. So, sin pi by 3 is root 3 divided by 2. So, again sin pi by 3, you have the root 3 by 2. Sin 2 pi by 3 is also root 3 divided by 2. So you got the maximum point, it is 3 root 3 divided by 2. This is the answer. We'll continue in the next class. Thank you.